Tom bought a 100,364-day Treasury bill for $19,560.50. What yield rate is implied? So for this Treasury bill, we have both the purchase price and the maturity value. The maturity value is 100,000. The purchase price it's 98,560.50, and it's a 364-day Treasury bill. In order to calculate the yield involved in this transaction, knowing that we were able to buy this Treasury bill for $98,560.50, we need to calculate first the overall return, expressed into dollars. So we have 100,000, the maturity value, minus the discounted value, the purchase price. So if we calculate this return, so once more, we have the emulator here, 100,000 minus the purchase price, we have an overall return of $1,439.50. So the rate is the amount of return divided by purchase price and divided by time. So we have $1,439.50 divided by purchase price and divided by time, 364, that we convert into years, so we divide by 365. So if we calculate this rate, we divide the overall return, divided by, we open bracket, 98,560 decimal 50 times 364 divided by 365, we close bracket, equal. We multiply by 100 to have the rate expressed as percent. So yield is 1.4645. For part B, we have the Treasury bill was purchased on August the 3rd, 2011. So Tom purchased it here on August the 3rd for $98,560.50. Tom sold it to another investor on October the 12th, 2011. October the 12th, 2011 for $99,102.10. What yield rate did the other investor wish to earn? So once more, we have a Treasury bill with a face value of 100,000. The other investor bought it at a discounted value of $99,102.10. In order to calculate the rate, we calculate first the overall return expressed into dollars as the difference between the maturity value of the Treasury bill and the purchase price. So this investor paid for this Treasury bill $99,102.10. So if we calculate this value, we have 100,000 minus 99,102 decimal 10 equal $897.90. And now we calculate how many days we have between August the 3rd and October the 12th. So second date, August is the 3rd. August the 3rd. August is the 8th month of the year, so it'll be the 8.03.11. October the 12th, 2011. October, it's the 10th month of the year, so it'll be 10.12.11. Arrow down, we compute the number of days between dates. So we have 70 days between August the 3rd and October the 12th. Between October the 12th and the maturity date, we have the remainder up to 364. So 364 minus 70, we have 294 days. So to calculate the rate, we have the overall return expressed into dollars divided by purchase price and time. So we have a return of $897.90 divided by the purchase price for second investor was $99,102.10 and the time 294. We divide by 365 to convert into years. So we have $897.90 divided by, we open bracket, 99,102 decimal 10 times 294 divided by 365, we close bracket, equal, and we multiply by 100 to have the rate expressed as percent. So second investor realize a rate of return of 1.1248. For part C, we have what rate of return did Tom end up earning. So Tom had this treasury bill between August the 3rd and October the 12th. So he kept this treasury bill for 70 days. He paid for this treasury bill $98,560.50, and he received, by selling to another investor, $99,102.10. So his overall return expressed into dollars will be the difference between how much he received and how much he paid. So we calculate this return. So it will be once more 99,102 decimal 10 minus 98,560 decimal 50. So will be an overall return of $541.60. And his rate of return will be $541.60 divided by the purchase price is $98,560.50, and he had this treasury bill for 70 days. Let's calculate this rate. So we divide the return of $541.60 by the purchase price, $98,560 decimal 50, and by that time, which is 70, divided by 365. Similar, we multiply by 100 to have the rate expressed as percent. So Tom has an overall return of 2.8653, keeping this treasury bill for 70 days.